Okay, we have a news helicopter descending along a helix. Now, remember, helix is that, yeah, so it's going to look basically something like this, that the newspaper helicopter is descending along this path, sort of coils around, goes under here, continues that, and at a certain spot though, at t equals 5, let's just mark it off as, I don't know, like here, t equals 5, the crew turns on a powerful headlight shining straight ahead in the direction of the velocity vector. You know, the velocity comes off tangent. They shine a light in the direction of the velocity vector. Now this light's going to come down and hit the ground, which is the XY plane someplace. And the question is, where? Find the point here where it hits the XY plane. Alright, great. So, R of t is the position vector. That's your helix equation, sine pi t cosine pi t 10 minus t. Now, the velocity vector is the derivative here. That'll be your velocity vector, and at any time t, that's going to be pi times the cosine of pi t minus pi times the sine of pi t minus 1. Okay, great. Now, what we're going to do is come up with the line that represents the beam of light. Parametric equation from the line requires a point and a direction. We have the direction vector at any time t, but we're interested at time t equals 5. So v of 5 will serve as the direction vector. And that's going to be, let's see, I'm going to put a 5 in for t. T equals 5. So cosine of 5 pi is negative 1. So we get negative pi. But the sine of 5 pi is 0. So this is the direction vector for that beam of light line. A point on the line would be, when we start it at time t equals 5, this particular point here, this purple point, this point I have represented by this purple dot here, is going to be, it's going to be a point. It's going to be a position. I'll write it as a point. If I put a 5 in there, I'll get sine of 5 pi, cosine of 5 pi, which is negative 1, 10 minus 5, which is 5. That gives me that point out in space. And so then, once I have this point in this direction, I know how to make the parametric equations for the line. I take the point and make that 0, -1, and 5. Put the point there, and then the direction vector, the coordinates A, B, and C there, components, get multiplied by t. So minus pi t plus 0t minus t. So that's the line that represents the beam of light. And so it's now our job to find the place where this particular line will intersect the XY plane. At what point on the XY plane does this beam of light hit? So we're going to say that the XY plane is given by the equation z equals 0. And so if z is 0, then we can find the time it takes to get to there. Z is 0 implies that t is 5. It takes 5 seconds for the beam of light, or it takes 5 units of time for the beam of light to go from the point on the curve down to the XY plane. And now we can take this t equals 5 and plug it into the XY and find out what that point XY is. We'll find out that x is -5 pi and y is -1. So that's the coordinates for this point. That's the answer to the question. It's not drawn to scale or anything like that. I'm not in the first octant, but yeah, that's the answer to the question. Yeah. All right, great.